Chapter 2, Exercise 2.93, Part A. The binding energy of electrons in a metal is 201 kilojoule per mole. Find the threshold frequency of the metal. What's the threshold frequency? It's the frequency of a photon that has enough energy to remove one electron from the metal. How much energy does it take to remove one electron? Well, we don't have this information. We have the amount of energy required to remove 1 mole electrons. So, first step, we convert this to joule per electron, and that would be the amount of energy of the photon. And then we have the energy of the photon divided by the Planck's constant. We'll get the frequency. So I'm going to use Wolfram Alpha to do the calculation. First, we have 201 kilojoule. 1 kilo is 1,000. So we have 201,000 joules. Now divided by the Avogadro constant to get the amount of energy required to remove a single electron. Alright, how much energy do we need? 3.34 times 10 to the power of negative 19 joule. And that's the energy of the photon. Alright, we need a photon with this much energy. Finally, we have the energy of the photon divided by the Planck constant. We will get the frequency. The frequency would be 5.04 times 10 to the power of 14 hertz, or inverse second. Alright, so I'm gonna just copy this number here, 5.04. Let's look at mastering chemistry solution over here. So this is the amount of energy required to remove 1 mole electron. And then we have this divided by the Avogadro constant. We also convert kilojoule to joule. So on top, 1, 2, 3, there are 3 terms. The product of the 3 terms would be the amount of energy required to remove 1 electron. And that's the minimum energy of the photon we need. The energy of the photon divided by the Planck constant, we get the frequency. This is second to the power of negative 1, or inverse second, or hertz. So again, the key is to convert kilojoule per mole to joule per electron. And then you use this amount of energy to compute the frequency of the photon.